So hi there. I'm looking to integrate a slightly awkward function, which is a product of an exponential and a trig function, so e to the x sine x. Now the problem with this is integrating by parts. Both e to the x and sine x are what are called cyclical functions. So when you integrate or differentiate, they go round and round. So if we're going to integrate by parts, we need to establish what we're going to use as u. Well, actually, it doesn't really matter because if I differentiate e to the x, I'm going to get e to the x from my du dx component. And likewise, if I set dv dx for by parts as sine x, if I integrate or differentiate, you're going to get some variation of cos x. So so cos differentiates to negative sine, so sine integrates to negative cos. Okay, so if we plug everything into my integral, I'm just going to call that I just for simplicity's sake. So now I is going to be equal to uv, which is u times v, which is negative e to the x cos x. It's conventional to put the exponential in front. You don't have to. And then I'm going to subtract the integral of v du dx. So we're obviously multiplying v du dx, so my negative there will turn out positive, and then we end up with e to the x cos x dx. So you notice we've got something on the right that looks remarkably similar to what we started with only one difference. We've got cos x instead of sine x. Now, if we went through that process again, then cos x would then turn back into sine x, which may actually help us out. So let's go for it. So again, we're going to use u equals e to the x. So du dx doesn't change. And then dv dx, we're going to set as cos x. Sine differentiates to cos, so cos integrates back to sine, so cos, so v is equal to sine x. Once again, plug everything back in. So our integral now becomes negative, just make that clearer, negative e to the x cos x plus, now this is going to be our new integral, so it's going to be uv, so I'm going to put this in square brackets. If this is negative outside, it's going to affect everything inside. It isn't, but you need to be careful by putting square brackets in place. So uv e to the x sine x minus the integral of v du dx. Notice we have e to the x sine x, which is what we started with, and close off our square brackets. So what I can do is I can rewrite this. I equals, I've done the same as last time, I equals negative e to the x cos x plus e to the x sine x minus our integral that we care about up here, the e to the x sine x. And you'll notice on both sides we have our I. So if we add it to both sides, we get 2i equals negative e to the x cos x plus e to the x sine x. So the integral on its own is obviously half of that, so negative a half e to the x cos x plus a half e to the x sine x. It's usually nicer to put it round the other way, but I'm actually going to leave it as it is. Oh, plus r, c. Okay, thanks.